Print. Today we are going to discuss about collections. What is collection framework? How we use collection framework? And what are the different implementations of collection? We'll discuss all these details in this session. So before we discuss, let us talk about collection of values. How can we store a collection of values? We can store a collection of values using array as well. So why are we choosing collection when we have arrays? So what is wrong with the array? What we can do and what we cannot do with arrays? Okay, then we'll discuss about collection framework. Let us talk about arrays for a while. What is array? Array is a collection of similar type of elements which are stored in a consecutive memory locations. So array is the one variable under which a set of values are stored. So how can we refer those values? Using index. Index starts from 0 to n minus 1 if the array size is n. Okay, so what are the advantages of array? We can access it by index. We can give index, we can get that value directly. We can also start accessing from first element to last element. Okay, this is fine. What is that we cannot do with arrays? For example, if I have created array of size 10, I can store 10 elements whose index starts from 0 to 9. So yes, we can store 10 elements. What we cannot do with array, we cannot increase or decrease the size of array, because once we create array with a specific size that is fixed, we cannot change the size. This is one of the issues with arrays. And what else we cannot do? So let us say, for example, we are storing a set of values. Let us say exactly 10 values we have stored. So if I want to store any one different value or different type of value, if I have created array of integers, we can store only integer type values. We cannot store other than integer. You cannot expect an array which has one boolean, one int, and one double. That is not possible when we create array with a specific size. So these are the problems we have with arrays. So in order to overcome these limitations, we have collection framework where everything is implemented and everything is taken care, including size and type. We just have to use the implementation that is their part of Java API. Okay, now let us talk about what is collection and what is the root interface of collection framework and what are the sub interfaces and what are the implementations of each interface and how they work. Let us talk about it. What is collection framework? Collection framework is a unified set of classes, interfaces organized in such a manner where we can deal with a huge number of objects. What is collection? Collection is an object or a container which can have a set of objects. It means one object contains so many objects. So we can perform some operations on a group of objects using collection framework. So when we take a group of objects, all the operations that we want to perform, we can do it just by calling some methods which are already implemented. We need not write code from the scratch. For example, if you want to create a collection, we simply need to create an object. If you want to add some element to the collection, we just need to call a method which takes care of adding. If you want to sort elements of a collection, we just need to call a method which will rearrange elements to get it sorted. So all these implementations are available. This helps programmer to develop application faster, and it saves a lot of time for the developer to focus on something that is not predefined. Okay, now let us see what are the implementations of, what are the interfaces of collection framework. Yes, the super interface of the collection framework is collection. Collection is the super interface. Collection framework classes, interfaces, abstract classes, exceptions, all these are available in a package called java.util package. In this package, we have interfaces and their implementation classes. Let us discuss about interfaces first. As you can see here, this is collection is an interface which has common functionality that we will do with any type of collection. Now let us see what are the implementations of the collection interface. Collection interface implementation. First one is list. List is an interface, or we can say sub interface of collection. Collection is a super interface and list is sub interface. So list is a type of collection which stores values. Those values can be referred using index. It is very similar to accessing array elements. So we can have a positional access for this. And this list can have a set of values which can contain duplicate values and nulls, that allows repeated values and nulls, which has positional access, allows positional access, or you can say no, random access. This list allows nulls and duplicate values, duplicates, where this allows us to have a positional access. Positional access to those elements. So this is about list. There are implementations. If we talk about each implementation, there is a slight difference in how they add and how they remove and how they retrieve elements. Now this list talk about the common operations that we do with every implementation of list interface. Now the another interface is set. Set is another subclass, or sorry, subinterface of collection interface. So this interface can store a set of values. It is very similar to list. There are some differences compared to list. This does not allow nulls and duplicates, and there is no positional access for those elements. Means those are accessed randomly. So there you cannot expect any position of the element. When you try to retrieve those values, first time you will get some way of displaying all those elements. Next time you will get some unexpected order of displaying elements. There is no order. No nulls and duplicates. And there is no positional access. There is no positional access of those elements. There is no order. So the order, there is an order ordered by index. The elements are ordered by index in case of list. Ordered by index, where there is no order. For set. Now there is another type of subinterface for collection is queue. Another subinterface is queue. So this is one of the data structures. You might have heard when people were discussing data structures like stack, queue, and linked list. So this is very similar to that. This allows certain order of insertion and certain order of removal of data. So what is the order of insertion and order of removal? It follows first in, first out. First in, first out for accessing elements. This is also a collection which has specific order and order of removal and insertion of those elements. Okay, now let us talk about the implementation classes of list and implementation classes of set and implementation classes of queue. So if we talk about implementation classes of list, we have two implementation classes for list. Those classes we use very frequently. First one is array list and linked list. These are two implementation classes for list, and for set, as set, preset, and linked has set. There are three implementations. We are discussing those which we use frequently. There are other implementation classes that we are not focusing on because these are essential to learn in collection framework. So has set tree set and linked hash set are three different types of implementations of set interface. If we talk about queue, the linked list class, same linked list class that is implementing two interfaces. One is list, the other one is queue. So if we use linked list, by calling some methods, we can get the functionality of queue. We will see how to use linked list, the way queue has to work, and how to use linked list, the way stack works. So that we'll discuss later. Now let us see what is array list and what is linked list. Let us talk about differences between these two implementation classes. So linked list is a type of collection which internally stores all elements in an array. It creates an array internally and all those elements are stored in array. So as we are already aware, as we have already discussed in the beginning of this session, we have discussed about arrays. Arrays has two drawbacks or limitations. It cannot store different types of values. That is one. And once the array is created, the size of array is fixed. So as we have these problems, why the array list is using again array? Because it is internally doing so many other operations to ensure that it has to grow its size when we are adding some elements, and it has to reduce its size automatically when we are removing elements. The advantage of using any type of collection is we can add any type of value to the collection, and the collection will automatically, the size of collection will automatically grow when we are adding elements, and the size of collection will be automatically decreased when we are removing elements from the collection. So we need not worry about the size of the collection. We just have to take care of adding and removing by calling some methods. Okay, so how that array list manages to ensure that it has to store all the values that are given by the user at a specific point of time. Okay, now let us discuss about this. Initially, when we create array list, it will create an array of a particular minimum size. Let us say, for example, 10. If you add some values, if it is 75% full, then array list will automatically create a new array. The size of the array is more than the previous array size, and it will copy elements of the previous array to the new array, and new elements that we add will be stored in a newly created array. So every time we add some elements, it will internally create a new array with the required size. It may be greater than the previous array, or the size may be lesser than the previous array, depending on what type of operation you are doing. If you are frequently adding elements, every time it will create a new array with a greater size. If you are removing elements, it will create new array with a lesser size. So it is, array list is able to manage to store all those elements by creating new arrays with the required size. So we need not worry about when it has to create a new array. So it should copy all those elements of the previous array to the newly created array. So these all taken care by the implementation of array list. We just have to call some methods which will do some required operation. So the advantage of the array list is it allows us to access elements using index. This is especially used when we want to access elements randomly. This is not recommended if we are removing elements very frequently. Internally, the array list has to do a lot of work, as we have discussed, creating new arrays and copying those elements. So it will take more time in order to add new elements and removing existing elements. It is very good for accessing elements from the array list. Now let us talk about linked list. This you might have heard in C and data structures topic. Linked list. As you can recall data structure concepts, if you are already aware, you can recall all those concepts. What is linked list? Linked list is a collection of nodes, and each node contains two parts. One is data and the other part is address. So data can be of any type, and the address is a memory location address which points to the next node. If there is no next node, then the second part contains null. If it is null, it is the last node. So this implementation is already given using a class linked list. That is one of the implementations of list interface. So the elements are organized the way we normally create linked list, or we have studied in C and data structures. So there are set of nodes. They are linked by the address. They are not in order physically. They are randomly allotted memory locations, randomly reserved memory locations. There is no order in the physical memory area, but there is an order logically. So how that order is defined? Order is defined by giving the address of the node, current node. Next node address will be given to the current node. So order is defined using addresses. And how can we use this? What is this good for? And what is this we cannot recommend? If we talk about how it insert and how it delete elements and how it access elements, we'll come to know exactly how it is working. So if we talk about linked list, if you want to add a new node, we can normally internally what it will do is it will create a new memory location and change the address. Previous node locations will not be changed. Only the link will be changed. So adding a new element to the linked list will not disturb the other elements. If you want to remove any node in the middle or the first node or last node, we just have to remove the link. If you remove the link, then that node or that element will not be part of the linked list. So it is very easier and very faster in terms of insertion and removal operations. So if I want to access elements, how can I access elements of linked list? Suppose let us say I have a linked list of 10 elements. I want to access fifth element. So we cannot access fifth element directly because we don't know where fifth element is located. If they are in order, like the array is reserving memory location, if there is an order, yes, we can go to location directly. In linked list, there is no order. If I want to access fifth element, how do I come to know where is the fifth element? Who knows that where is the fifth element? Fourth element knows. How do we know where fourth element is? Third element knows. So anyhow, we have to start from the first node to go to fifth node. Without starting from the first node, we cannot reach fifth node. Means when we try to access elements of linked list, there is certain order. We have to start every time from the root node or first node in order to reach the required node. So as you can understand, this is not recommended for retrieving elements. It is good for faster for insertion and removal operation. And array list is good for insertion and removal, and we can also use it for accessing. But here insertion and removal, yes, as we have discussed, it takes more time for insertion and removal. It is good for accessing elements, and this is good for insertion and removal of elements. I hope you have understood the distinction between array list and linked list. Now we'll have a look at some programs where we will be able to understand array list and linked list. Yes. Now we'll create a new project. Let us create a new class. The class name is array list demo. Please don't create a class, don't use class name that is already part of Java API. Don't create arraylist.java. Create a class name which is completely different or a slightly different from the existing classes, so that we can easily differentiate predefined class and the class which we are creating. Now, let us create ArrayList object. To create ArrayList object, ArrayList al equal to new ArrayList. This creates object of ArrayList. We need to import ArrayList from java.util package. Now we can add any type of elements to this ArrayList. This is integer we are adding, and we can add double value. We can add boolean. If you want to print, we can print it just by calling toString of ArrayList. Println al. It calls toString of ArrayList, which prints all the values. Let us have a look at the output. Yes, you can see values are printed. It is taking different types of values. We just have to figure out some methods which helps us to add. As we can guess, we have method names like add, remove, add all, remove all. You have methods like this where you can easily find out what it is going to do based on the name of method. We can also restrict the collection to a specific type using generics. Yeah, how can we how can we restrict this array list to a particular type? We can use generics. So we can use integer. If you use integer, then it allows only integer type of values. It will not allow any other type of values. You can see here there is no error at the time of adding 10, but there are errors while adding double value and boolean value. If you have a look at the error message, you can see the message here, add integer in the type array list is not applicable for argument double. And similarly, it is not applicable for arguments boolean also. So it will take only, array list can take only integer type of values. We are sticking to a particular type by specifying this class name. You can give boolean here, you can give character, you can give string. You can also give your own class name where only objects of that class will be added to array list. Now we'll see how to print values using for loop. How to print values using for loop. For index equal to 0, index less than, there is a method called size which returns the number of values in the collection. Increment index by 1 every time, and then system.out.println air dot, you have get method which gets the element from a given index, and that will be printed. Now we can use this for loop to print elements from collection. Run as Java application. Yes, for loop is printing values from the collection. You can also use linked list in place of the array list here. So you have same set of methods, but the internal implementation is completely different from add method of array list and add method of linked list. We have same method with the same signature, but how it is adding internally, what are the rules for adding, and how it has to link from one element to other element, that is completely different from array list to linked list. The similar same way we use. Let us talk about set. So set has hash set, tree set, and linked hash set. Hash set stores a collection of values. There is no order for hash set. This allows one null value. This allows null. This will not allow duplicate. When we talk about set, we say that there are no nulls because we are not talking about specific implementation of set. We are talking about set. When we talk about specific implementation, there are slight differences from one implementation to the other implementation classes. So here, has set allows null, it will not allow duplicate values. If we talk about tree set does not allow null and duplicate values, and all the tree set values are in a particular order. So if you are adding some names, those names will be in alphabetical order. If you are adding numbers, there will be numerical order. If you are adding some date values, there will be chronological order. So tree set has these features, not only rejecting nulls and duplicates, it also places all those elements in a order. If we talk about linked hash set, is a kind of linked list implementation again here. Is very similar to this. Only thing is here for linked list we have index. Based on index we can access here. Here in linked hash set, it will maintain the insertion order. Whatever order you insert, in the same order you get those values. If you want to retain that order of insertion, we have to use this particular implementation. This is linked hash set. So now let us create hash set and let us try to add elements, and let us see one program using hash set. The class name is hashset demo, where we create object of hashset. Import it from java.util package. You can add any type of values. One is integer, other one can be float, boolean. You will be able to add. If you want to restrict to the hash set elements to a particular type, then the way we have given for array list, the same way we have to give type for hash set as well. Want to print elements. Yes, you can see values here. You can see there is no order of displaying those values. You can specify particular type after hash set. Within angular braces, you can specify type to restrict the collection to that particular type, or if there is no type, then it can accept any type of values. The same way, the way we have used array for loop for array list, we have size. This is a common method for all implementations. We can use the same for loop for displaying values of hash set. We can also use tree set where values are arranged in order. Let us create hash set. Yeah, hash set we have created. Let us create tree set. and then add some values and display them. Just add some values. Now we are adding some values. There is no order for these elements. We are adding numeric values. There is no numerical order of adding elements. But if we try to print them, there will be numerical order. We just print it using system.out.println. You can see values are printed in numerical order. You can see the minimum element is first and the maximum element is last. So it will automatically arrange them in order. We try to add null. There will be null pointer exception. It will not take null values. So there is no error at compile time, but there is a problem, the exception at runtime. It will not take values. So the same values you can print it using for loop, using size method. You can also add, let us add some alphabetical, let's see alphabetical order of some names. Let us say James. James, Adam, Ward, and Miller. Let us print it. See the order of printing. You can see Adam printed first, Ward printed last. If you arrange them in alphabetical order, this name comes first and this name comes last. The other names also in order. So if you want them to be printed or retrieving in order, then we can use preset. If we don't need any order, then we can use hash set. If you want to maintain that the order that we have inserted, if you want to retain that order, then we can use linked hash set. Yes. Now let us see how to make use of linked list in different ways. How to use linked list. Linked list is one of the implementations of the list interface, where this linked list has different functionalities depending on how we use linked list. It works different ways. So there are some methods. Basically, we use two methods. One is for adding, other one is for removing. If you want to use linked list as a normal linked list, like linked list should behave as the same as the linked list works. The linked list class should work same as linked list functionality. Then we have methods called add and remove. Add is to insert new element to the linked list. Remove is to remove it from the linked list. So these two normally we use. If we want that linked list should behave as a stack functionality, then we have other methods where if we use those methods, linked list will behave as stack. So there are methods called push and pop. Push is for inserting new element, pop is for removing element. So these two follows stack rules. What are these rules of stack? It is first in last out or last in first out. So this, if you try to push, it will be added at the end. So if we use add, so we can add at a specific position. So how add works and how push works, that is completely different. Push and pop, these two methods follows the rules of stack for insertion and removal operations. So if we use other two methods where linked list will behave as queue, there are methods called offer and poll. If we use offer and poll methods, offer is for adding elements, poll is for removing elements. Using these two, we can use this linked list will behave the way queue has to work. So what is the order of insertion and order of removal for queue? It is first in, first out or last in, last out. So how linked list has to behave, that is depending on which two methods are we using. If we are using first two methods, it will behave as a normal list. If we use push and pop, then it will behave as stack. If we use offer and poll, the linked list will function same as queue functionality. So linked list, as we have already discussed, we can use linked list. So we have other implementations for queue also that we will discuss in further sessions. Now let us see one example for linked hash set. Let's create a new class. Create linked hash set object. Yes. Now you can observe the order we added. First we have added 10, that is of type integer. Next we have added true, that is of type boolean. Then we have added 3.14, that is of type double. If you have a look at the output is also in the same order: 10, true, and 3.14. So as we have already discussed that linked list will preserve insertion order. It will help us to retrieve the elements in the same order that we have inserted. So when that order is required, when insertion order is required, then we must use linked hash set. I hope that you have understood. So what is collection? What are the different implementations? What are the different interfaces of collection framework and different implementations of collection framework? How can we use it? How can we restrict a collection to a specific type? How can we add different set of values and how to retrieve them? So what is the one which follows order and what is the one which does not follow any order? What type of collection which allows nulls and duplicates? What type of collection does not allow duplicates and nulls? These are the very important things to remember. Yes. Today we are going to wind up this session for now. So next time we'll meet with a new topic. Thank you.